You know what? I woke up this morning, made my coffee, and checked my phone like I do every day. And there it was. Another video of a Chinese robot dog doing backflips while carrying a machine gun. Just another Tuesday in 2025, right? But here's the thing that actually made me stop scrolling. It wasn't the robot itself, it wasn't even the weapon. It was the comments section. Thousands of people arguing about whether this is progress or the beginning of the end. And honestly, both sides have a point. Look, I've been covering technology for years, and I've seen a lot of hype cycles come and go. But what's happening with robots right now is different. This isn't some distant future we're talking about. This is happening today, right now, while you're listening to this, and I'm not going to sugarcoat it. We need to talk about what this really means. So forget everything you think you know about robots. Forget the movies, forget the sci-fi novels. What I'm about to show you is the real story of how robots went from lab experiments to million-unit production runs in less than 2 years. And trust me, it's wilder than anything Hollywood could dream up. Let me take you back for a second. Remember 2020? We were all stuck at home, baking sourdough, and watching Boston Dynamics robots doing dance routines on YouTube. It was cool, it was impressive, but it felt distant, like, yeah, that's neat. But what does it have to do with my life? Fast forward to today, and everything's changed. And I mean everything. The transformation didn't happen overnight. But when you zoom out and look at the timeline, it's absolutely insane. In 2020, we had maybe a dozen companies worldwide doing serious robotics work today. There are over 300 startups in China alone. And that's not counting the US, Japan, Korea, or Europe. The money flooding into this space is astronomical. We're talking about $50 billion in investment just in the last 18 months. But here's what really matters. The robots themselves have fundamentally changed. In 2020, if you saw a robot walking, it was probably on a treadmill in a lab, with engineers ready to catch it when it fell. Today, these things are climbing mountains, working factory floors for 12-hour shifts, and being tested for military applications, the breakthrough that changed everything. It wasn't just one thing, it was the perfect storm of 3 major advances happening at the same time. First, AI got scary good, and I don't mean chatbots that can write your emails. I mean vision systems that can identify and manipulate objects in real time, learning algorithms that let robots teach themselves new tasks overnight, and decision-making systems that can handle unpredictable environments. The same transformer architecture that powers ChatGPT. It's now running inside robots, helping them understand and navigate the world in ways that were impossible just 3 years ago. Second, the hardware got cheaper. Way cheaper. Remember when a single robotic joint cost $10,000? Now you can get the same performance for $200. Why? Because China built an entire supply chain around robotics components, and they're cranking them out at a scale that would make Ford jealous. This isn't just good business. It's a strategic play that's reshaping the entire industry. And third, and this is the one people don't talk about enough, the manufacturing infrastructure finally caught up. Companies figured out how to mass produce these things, not just building prototypes in labs, but actual assembly lines spitting out hundreds of robots per month. That's the game changer right there. So that's how we got here, but where exactly are we? Let me break down what's actually happening on the ground right now. Okay, let's talk about China. And I'm going to be straight with you. What they've accomplished in the last 18 months is both impressive and terrifying. Depending on how you look at it, I want you to imagine a factory in Shenzhen. Not tomorrow, not next year, but right now, inside that factory, there are production lines building hundreds of humanoid robots every single week. Not toy robots, not prototype robots, fully functional. Industrial-grade machines that can work alongside humans, lift 50 pounds, and operate for 12 hours on a single charge. The company doing this is called Agabot, and they're not the only one. But they're the one that made everyone in Silicon Valley nervous when they announced they'd built nearly 1,000 humanoid robots by the end of 2024. Tesla's been talking about Optimus for years and promising mass production by 2026. China just did it 2 years early, and here's the kicker. These aren't cheap knockoffs. The Pudu D9 humanoid stands 5.5 feet tall, can navigate stairs, has advanced AI for object recognition, and costs somewhere between $20,000 and $30,000. That's roughly what Tesla is promising for Optimus, except you can order a Pudu today. But let's rewind because the humanoids are just part of the story. The thing that really got the world's attention? The robot dogs. Now I know what you're thinking. Boston Dynamics has had Spot for years, that's true. But what Unitree is doing with their B2 and B2W models is on another level, not because the technology is necessarily better, but because of the scale and the applications. The B2W can do somersaults, it can climb mountains, it can carry a full-grown human on its back, and it has wheels on each leg, which means it can roll downhill at speeds that would make your head spin. Imagine trying to outrun something that can switch from walking to sprinting to rolling at 30 miles per hour. You can't. That's the point. Then there's what people are calling the Black Panther, a quadruped robot that can run 100 meters in under 10 seconds. Let me put that in perspective. Usain Bolt's world record is 9:58 seconds. This robot is essentially at Olympic sprinting speed, and it's getting faster. The engineers at Zhejiang University studied actual black panthers and desert rodents called jerboas, analyzing their biomechanics to create something that's not just fast but efficient. They gave it carbon fiber shins, special grip-enhanced running shoes, yes, robot running shoes, and an AI system that adjusts its gait in real time based on terrain. Why does this matter? Well, there's the civilian applications: search and rescue, inspection, delivery. But let's not be naive. When I see videos of these robot dogs with rifles mounted on their backs during military exercises, I'm not thinking about package delivery. And this brings us to the uncomfortable part of the conversation. China isn't just building robots for fun. There's a strategic plan here. The tensions with Taiwan are real. President Xi has allegedly told the People's Liberation Army to be ready for a possible invasion by 2027, the PLA's 100th anniversary. And guess what's been rolling off Chinese production lines by the thousands? Autonomous machines that can carry supplies, scout terrain, and yes, potentially engage in combat. The scary part isn't that these machines exist. The scary part is the sheer volume. When you can produce thousands of robots per month, you're not building a research project. You're building an army, and unlike human soldiers, robots don't get tired, don't need food, and don't hesitate. Now, before this sounds too much like a Michael Bay movie, let me be clear, we're not at Terminator levels yet. These robots still need human operators for complex decisions. They break down, they have limited battery life, they can be hacked or jammed, but the trajectory is clear and it's moving fast. The Chinese government has invested an estimated $100 billion into robotics over the last 5 years. That's not a typo, $100 billion. They're not playing around, and at the Consumer Electronics Show in Las Vegas earlier this year, about a quarter of all exhibitors were from China, showcasing everything from household helper robots to industrial machines to, yes, military-grade autonomous systems. So that's the Chinese side. Impressive. Absolutely concerning. Also, yes. But here's what a lot of people miss. The US isn't sitting idle. Let's talk about what's happening on American soil, because this is where things get really interesting. The United States has taken a completely different approach to robotics, and honestly, it's a strategy that might be smarter in the long run. Even if it looks slower right now, instead of focusing on mass production and getting numbers out the door, American companies are obsessing over capability. They're asking, what can these robots actually do? How dexterous can we make them? How intelligent? How autonomous? And nowhere is this philosophy clearer than at Boston Dynamics. Look, I've been following Boston Dynamics since their Big Dog videos went viral back in 2008. Remember those? The hydraulic quadruped that sounded like a swarm of angry bees. Yeah, we've come a long way. But what they've done with Atlas over the past 2 years represents a fundamental leap forward. The new Atlas isn't just about backflips and parkour, though it can still do those things. And honestly, it never gets old. What's changed is the hands. And I know that sounds simple, but stay with me because this is huge. The GR2 gripper that Boston Dynamics developed has 3 fingers plus an opposable thumb. That thumb, that's the entire game. The previous version, GR1, had 3 fingers all aligned. It could grip things, sure, but it couldn't manipulate them with any real finesse. Adding that thumb opened up a whole world of possibilities. Now Atlas can pick up irregular objects, adjust its grip on the fly, thread a needle, yes, thread an actual needle, assemble components, and handle delicate items without crushing them. That's not just impressive from an engineering standpoint. That's the difference between a robot that can work in a controlled environment and one that can actually help you in the real world. Think about it. Most tasks humans do require manipulation. Not just picking things up, cooking, cleaning, repairing things, assembling furniture. All of that requires dexterous movement. And that's what Boston Dynamics has cracked. the fingers can bend backward, which sounds weird until you realize it allows for some really clever grasping techniques. There's no fixed dominant hand. The AI decides which hand to use based on the task and environment, and the whole gripper module is self-contained, meaning you can swap it out or adapt it for specific jobs. But Boston Dynamics isn't the only player in this game. Tesla's been working on Optimus, and while progress has been slower than Elon originally promised, shocking. I know, what they're building is genuinely impressive. The latest version of Optimus can walk smoothly, maintain balance on uneven surfaces, and handle objects with increasing precision. More importantly, Tesla's betting on vertical integration and cost reduction. They're building Optimus with the same philosophy they used for their cars design, everything in-house. Optimize for manufacturing and drive the price down through scale. Elon's been saying Optimus could eventually cost less than a car. I'm skeptical of that timeline, but the logic is sound. If you can get a humanoid robot down to $20,000 or $30,000, suddenly it's not just for factories, it's for households. Then there's Figure AI, and this is the company that's been quietly making moves while everyone else was arguing on Twitter. Figure just announced their Figure 02 humanoid, and they're not messing around. This robot is designed from the ground up for real-world deployment. Not lab demos, it's lighter than previous models, has a 60% wider field of view from its cameras, can operate for 5 hours on a charge, and this is the part that got my attention. It charges wirelessly by just standing on a plate. But the real innovation is their AI system called Helix. This isn't pre-programmed movements. This is genuine learning through interaction. The robot watches, learns, and adapts. Figures claiming nothing is teleoperated, meaning when you see it doing tasks, that's actual autonomous behavior. They've also thought hard about safety. The robot's exterior is covered in soft, washable materials. There are no exposed metal parts that could pinch or cut. The sensors are sensitive enough to detect the weight of a paperclip. Why? Because if these things are going to work around humans, in homes, in hospitals, in offices, they can't be dangerous. Figure's ambitious. They want to produce 12,000 units per year initially, scaling up to 100,000 within 4 years. That's mass production, American style, not as fast as China, but with what they're hoping is better quality and capability. And here's something that doesn't get enough attention: NVIDIA's role in all of this. NVIDIA's Jetson Thor chip is being called a platform for physical AI, and it's basically the brain that powers a lot of these advanced robots. The computational power required for real-time vision processing, decision-making, and motor control is insane. You need to process multiple camera feeds, run complex AI models, control dozens of actuators, and do all of that in milliseconds. That's what Jetson Thor enables. So while China is winning on volume, the US is betting on capability and intelligence. It's the classic quality versus quantity debate, and honestly, we won't know who's right until these robots start doing real work at scale. But here's where things get uncomfortable. Because while we're all excited about robots that can fold laundry and help the elderly, there's another reality we need to face. The military is extremely interested in this technology. And I'm not just talking about robot dogs with guns, though that's certainly part of it. I'm talking about autonomous weapon systems that can make kill decisions without human input. Swarms of drones that can overwhelm defenses through sheer numbers. AI-powered targeting systems that never miss. The US and China are in what experts are calling an AI arms race, and it's escalating fast. Both countries are pouring billions into military robotics research. And here's the scary part: unlike nuclear weapons, there's no treaty banning autonomous weapons. There's no Geneva Convention for robots. Some researchers are calling these slaughter bots or butcher bots, and while those terms sound dramatic, they're not entirely wrong. Imagine a swarm of small drones, each one powered by AI, programmed to identify and eliminate specific targets. They're cheap to produce, hard to defend against, and once deployed, almost impossible to stop. And unlike human soldiers, they don't feel fear, they don't get tired, and they don't have moral qualms. Now, proponents argue these weapons could actually save lives by reducing collateral damage and taking soldiers out of harm's way. And maybe that's true. But critics point out that lowering the cost and psychological barrier to conflict makes war more likely, not less. The United Nations has been debating this for years, but progress is slow because, surprise, the countries with the most advanced robotics programs don't want restrictions. The US argues that autonomous weapons could be more precise than human operators. China argues that defensive autonomous systems are necessary for national security. Russia's doing their own thing. And meanwhile, the technology keeps advancing. Here's my take, and this is just my opinion. We're sleepwalking into a future that we haven't really thought through. We're building these systems because the technology is there, because the other side is doing it. But are we asking the right questions? Who's accountable when an autonomous weapon makes a mistake? How do we prevent terrorists or rogue states from getting this technology? What happens when these things start getting hacked? I don't have the answers. I don't think anyone does. But I know we need to be having this conversation now. Not after the first major incident, okay? Let's step back from the doomsday scenarios for a minute and talk about what's actually happening with robots in everyday settings. Because while the military applications get all the headlines, the real revolution is happening in places you might not expect. Let's start with factories because that's where most robots are deployed right now. I visited a warehouse in Ohio last month. Can't say which company, but it's one of the big ones. And what I saw blew my mind. There were humanoid robots working alongside human employees. And not in some segregated section. We're talking side-by-side collaboration. The robots were unpacking boxes, sorting items, moving stuff around. And here's the thing, they were actually useful. The floor manager told me something interesting. He said the robots aren't replacing workers, at least not yet. They're filling positions he can't hire for. The warehouse has been short-staffed for 2 years because nobody wants to work night shifts doing repetitive physical labor. The robots? They don't care. They'll work 24/7 if you want them to. And this is playing out across the manufacturing sector. Tesla's using robots in their factories. Amazon's been deploying them in fulfillment centers. BMW has humanoids working on assembly lines. These aren't experiments anymore. They're operational deployments. But here's where it gets complicated. Right now, these robots are expensive. A single humanoid might cost $50,000 to $150,000 depending on capabilities. Add in maintenance, training, and infrastructure. And you're looking at a significant investment. For a major corporation, that's doable. For a small business, not so much. So what we're seeing is a two-tiered system emerging. Large companies with capital can invest in automation and become more efficient. Smaller companies that can't afford it fall behind. It's creating a competitive advantage that has nothing to do with business acumen or product quality. It's just about who can afford the robots. And that brings us to the question everyone wants to avoid. What about jobs? Look, I'm not going to lie to you and say robots won't impact employment. They will. They already are. But it's more nuanced than robots steal all the jobs. What's happening is certain types of jobs are disappearing. Repetitive physical labor, basic data entry, routine inspection tasks. But other jobs are being created. Robot maintenance, AI training, automation specialists. The problem is, the people losing their jobs aren't necessarily equipped for the new jobs being created. A 50-year-old factory worker who's been doing the same task for 20 years can't just retrain as an AI specialist. That's not realistic, so what happens to them? This is where policy needs to step in with retraining programs, social safety nets, and transition support. But honestly, most governments are way behind on this. And it's not just manual labor. White-collar jobs are next. AI-powered robots are starting to do things like legal research, financial analysis, basic medical diagnostics. If you're a radiologist looking at x-rays all day, AI can probably do your job better and faster. If you're an accountant doing tax returns, AI's coming for that too. The question isn't whether this will happen. It's how we manage the transition. Do we fight it and try to stop progress? That's never worked in history. Do we embrace it and let the chips fall where they may? That could create massive social upheaval. Or do we try to find some middle path where technology enhances human capability rather than replacing it? I tend to lean toward that last option, but I'm not sure how we get there. Now let's talk about robots in homes, because this is where things get personal. The idea of a household robot isn't new. We've had Roomba for 20 years. But we're talking about something different now. Genuine humanoid assistants that can do a wide variety of tasks. Imagine coming home after a long day and your robot has already done the laundry, cleaned the kitchen, and started dinner. Sounds amazing, right? But here's the reality check: we're not there yet. Not really, yes. Prototypes can do these things in controlled environments, but real homes are messy. There's stuff everywhere. Kids leave toys on the floor. Pets get in the way. The lighting changes. Objects move around. And current robots still struggle with that level of unpredictability. Plus, there's the creepy factor. Are you comfortable having a human-shaped robot in your home? Can it watch you, record you? What happens to that data? These are questions that don't have good answers yet. And let's talk cost. Even if we get humanoid robots down to $20,000, which is optimistic, that's still a car-level purchase. How many families can afford that? And for what benefit? If it can only do 60% of household tasks, is that worth the investment? Or are you better off hiring a cleaner once a week for $100? My gut feeling is that household robots will follow the same pattern as dishwashers or washing machines. They'll start as luxury items for the wealthy, gradually become more affordable, and eventually become standard appliances. But that transition will take decades, not years. Where I think we'll see faster adoption is in elder care. The population is aging globally. Japan and China are already dealing with this. In 20 years, the US will be too, and there simply aren't enough caregivers to meet the demand. Robots could help, not replacing human care, but supplementing it. A robot that can remind someone to take their medication, help them if they fall, monitor vital signs, and call for help if needed. That's genuinely valuable, and maybe that's less creepy than a robot doing your laundry. It's a tool with a clear purpose that helps maintain dignity and independence. Japan's already testing this, and early results are promising, but we need to be careful. Elder care requires empathy, emotional connection, and human judgment. A robot can't provide that. It can handle the physical tasks, but it can't replace human interaction. And if we're not careful, we could end up with elderly people isolated and lonely, surrounded by machines instead of people. All right, let's get into the weeds for a bit. Because if you really want to understand what's happening with robots, you need to understand the technology that makes them work. The biggest breakthrough in the last few years hasn't been the mechanical parts. Though those have improved dramatically, it's been the AI. Modern robots use something called Vision Language Action Models, or VLA for short. Essentially, these systems combine computer vision, natural language processing, and motor control into one integrated system. The robot can see what's in front of it, understand what you're asking it to do, and figure out the actions needed to accomplish that task. This is powered by transformer architectures, the same technology behind ChatGPT and other large language models. But instead of predicting the next word, these systems are predicting the next action. If I'm holding this cup and the goal is to place it on the shelf, what movement should I make next? What's wild is that these systems can generalize. You don't have to program every single task. You train the robot on a variety of tasks, and it can figure out new tasks by combining what it's learned. It's not perfect, far from it. But it's a fundamental shift from traditional robotics, where everything had to be explicitly programmed. The other major advance is in tactile sensing. Early robots were basically blind when it came to touch. They could grip things, but they couldn't tell if something was slipping, or how much force they were applying, or what texture they were feeling. Now, robots have sensors in their fingertips that can detect pressure changes as small as the weight of a paperclip. They can feel when something's about to slip and adjust their grip in real time. They can tell the difference between a glass bottle and a plastic one just by touch. This is what enables the dexterous manipulation we're seeing. Without tactile feedback, you can't do delicate tasks. You'd either drop things or crush them. But with good sensors and fast processing, robots can now handle eggs, thread needles, and manipulate fragile objects. On the hardware side, actuators have gotten way better. The motors that move robot joints are more powerful, more efficient, and more precise than ever before. Some robots are using series elastic actuators, which have a spring between the motor and the joint. This makes movement smoother and safer. If the robot hits something, the spring absorbs the impact instead of breaking whatever it hit. But probably the biggest hardware challenge is still power. Batteries are heavy and don't last long enough. A humanoid robot doing physical work might only run for 3 to 5 hours before needing a recharge. Compare that to a human who can work for 8 hours on just some food and coffee. There's research into more efficient motors, better batteries, even energy harvesting systems. Some robots can already recharge themselves by walking over special floor plates, but we're still a long way from robots that can operate continuously without human intervention. And then there's the question of computation. Running advanced AI models requires serious processing power. That's why robots have these chunky backpacks or torso units. That's where the computers are. NVIDIA's Jetson chips are helping. But there's a constant tension between computing power, energy consumption, and weight. The holy grail would be a robot with human-level intelligence, human-level dexterity, 16-hour battery life, and a price under $10,000. We're not there. We might not be there for decades, but we're making progress on all fronts. Now let's talk about something that keeps cybersecurity experts up at night: hackable robots. Think about it. These robots are connected to the internet. They're running software that can be updated remotely. They have cameras, microphones, and increasingly, the ability to make autonomous decisions. What happens when someone hacks them? This isn't theoretical. We've already seen demonstrations of researchers hacking consumer robots to make them spy on their owners or move in unintended ways. And these were simple devices like Roombas and toy robots. Now imagine someone hacking an industrial robot in a warehouse, or a military robot on a battlefield, or a personal robot in someone's home. The attack vectors are numerous. You could exploit vulnerabilities in the software. You could intercept and manipulate the communication between the robot and its control system. You could even feed false data to the robot's sensors, making it see things that aren't there or miss things that are. And here's the really scary part. Most robots are running modified versions of Linux or Android. These are well-known operating systems with well-known vulnerabilities. The robotics companies are adding security, sure, but they're not security companies. That's not their core expertise. There's also the supply chain problem. A modern robot has components from dozens of different manufacturers: Chinese sensors, American processors, Japanese actuators. Who's verifying that none of those components have backdoors? Who's ensuring that the AI training data hasn't been poisoned? And we haven't even talked about what happens if someone weaponizes a consumer robot. Take a household robot, remove the safety limiters, give it a knife, and suddenly you have a very dangerous device. Most commercial robots have weak security precisely because nobody thought they'd be targets for attack. The solution isn't to ban robots or disconnect them from the internet. The solution is to take security seriously from the ground up. Encrypted communication, secure boot processes, regular security audits, bug bounty programs, all the stuff we do for critical infrastructure, we need to do for robots too, but right. Now, we're mostly ignoring this problem and hoping it doesn't blow up in our faces. Let's talk about the economics, because following the money tells you a lot about where this industry is really headed. The robotics market was valued at about $60 billion in 2023. By 2030, estimates range from $150 billion to $260 billion depending on who you ask. That's explosive growth, and investors know it. Venture capital has poured about $50 billion into robotics startups over the last 3 years. Tiger Global, Sequoia, Andreessen Horowitz. All the big names are getting in. Why? Because if even one of these companies figures out how to build a truly useful, affordable humanoid robot, they're looking at returns that make social media investments look quaint. But here's the thing about robotics. It's capital intensive. You can't build robots in a garage. You need manufacturing facilities, supply chains, R&D labs. That means these companies burn through cash fast. Figure AI has raised over $700 million. Agility Robotics has raised hundreds of millions. Boston Dynamics was sold by Google to SoftBank, then sold to Hyundai, because even with Google and SoftBank money, it was losing a fortune. The business model question is still open. Do you sell robots like you sell cars? One-time purchase with maintenance contracts? Do you lease them like enterprise software? Do you create a subscription service? Different companies are trying different approaches. Tesla's betting on ownership. They want to sell you a robot you keep forever. Figure AI is looking at leasing models. Some Chinese companies are trying robot as a service, where you pay per hour of use. And then there's the question of when these companies will actually be profitable. Because right now, most of them aren't. They're in the growth phase, sacrificing profitability for market share. That's fine when investor money is flowing, but what happens when the market turns? There's also the China factor. Chinese companies have access to cheaper manufacturing and often significant government subsidies. They can undercut Western companies on price, which creates a dilemma. Do you compete on price and sacrifice margin? Or do you compete on quality and hope customers will pay premium? My prediction? We're going to see consolidation. Right now, there are hundreds of robotics companies. In 5 years, there will be maybe a dozen that matter, plus a long tail of specialized niche players. The companies that survive will be the ones that can either manufacture at massive scale or can differentiate on capability. There are several aspects of the robot revolution that aren't getting enough attention, and I want to highlight them because they might be more important than the headline stuff. First, environmental impact. We're talking about manufacturing millions of robots. Each one requires rare earth metals. Lithium for batteries, plastics, aluminum. The carbon footprint of producing a single humanoid robot is significant. And what happens when these robots reach end of life? We already have an e-waste problem. Now imagine adding millions of 100-pound robots to that waste stream. Some companies are thinking about this. Figure AI is designing their robots to be modular, so components can be replaced or upgraded rather than throwing away the whole unit. But most companies aren't thinking long-term about sustainability because they're too focused on just getting their products to market. Second, the psychological impact. There's research showing that humans form emotional attachments to robots, especially if they look humanoid. We anthropomorphize them, we give them names. We feel bad when they're damaged. Now, is that a bad thing? Maybe not. But what happens when people start preferring robot companionship to human interaction? Japan's already seeing this with AI companions and digital partners. And while robots can provide comfort and reduce loneliness, they can't replace genuine human connection. There's a risk that we create a society where people are surrounded by machines but fundamentally isolated from each other. Third, the legal gray area. Who's liable when a robot causes harm? Is it the manufacturer? The owner? The AI training company? The person who is supposed to be supervising it? Current law isn't equipped to handle these questions. If a self-driving car crashes, we're still figuring out liability. Now multiply that problem across every domain where robots operate. A surgical robot makes a mistake during surgery. A police robot injures someone during an arrest. A household robot starts a fire. Who pays? Who goes to jail? We need legal frameworks for this. And we need them before the technology is widely deployed. But legal systems move slowly, and technology moves fast. That gap creates risk. Fourth, the accessibility divide. If robots become essential tools for work and daily life, but they're expensive, we create a new form of inequality. People who can afford robots become more productive and efficient. People who can't fall behind. It's like the digital divide, but potentially more severe. This is why some people are calling for robots to be treated like public infrastructure, subsidized or provided by the state to ensure equal access. But that requires political will and public funding, both of which are in short supply. Let me paint you 3 possible futures, because I think it's useful to think about this in terms of scenarios rather than one predicted outcome. Scenario 1, the optimistic future. In this version, we figure it out. Governments work with companies to create sensible regulations. We invest in retraining programs for displaced workers. Robots handle dangerous and repetitive jobs while humans focus on creative and social work. Productivity increases, and through some combination of taxes and redistribution, the benefits are shared broadly. Robots help care for the elderly, allowing them to maintain independence longer. They work in hazardous environments, mining, deep-sea exploration, disaster response, saving human lives. They enable new forms of manufacturing and construction, making housing and goods more affordable. The transition is bumpy, sure. Some people lose jobs. Some communities struggle. But overall, we adapt like we've adapted to every previous wave of technological change. In 2050, people look back and wonder why everyone was so worried. Scenario 2, the pessimistic future. In this version, we screw it up. The rich get richer as they deploy robots to automate everything. The middle class hollows out as white-collar jobs disappear alongside blue-collar ones. Governments prove unable or unwilling to provide safety nets, leading to widespread unemployment and social unrest. The surveillance state expands as governments use robots to monitor and control populations. Authoritarian regimes deploy autonomous weapons without restraint. Hackers and terrorists exploit weakly secured robots to cause chaos. The wealth gap becomes insurmountable. A small elite lives in automated luxury, while the majority struggles to find purpose and meaning in a world where they're economically obsolete. Social cohesion breaks down. We fragment into tribes. some embracing technology, some rejecting it violently. Scenario 3. The muddled middle. This is probably the most realistic. We don't figure it all out. But we don't completely fail either. Progress is uneven. Some countries handle the transition better than others. Some industries automate smoothly while others face conflict and disruption. Robots become common, but not universal. Most people interact with them daily but don't own one. They deliver packages, clean buildings, work in warehouses. But personal household robots remain expensive luxury items. There are incidents, hacked robots, accidents, misuse, but nothing catastrophic enough to stop the technology. The legal system slowly catches up through a messy combination of lawsuits and legislation. Labor markets adjust, but painfully, with certain regions and demographics hit harder than others. It's not a gleaming sci-fi utopia, but it's not a dystopian nightmare either. It's just complicated, which is how most technological transitions actually go. Which future do I think is most likely? Honestly, scenario 3, because that's how things usually work out. We muddle through, we make mistakes, learn from them, and adapt. It's not satisfying, but it's realistic. So after all this, you might be wondering, what now? What can you, as an individual, actually do with this information? First, if you're in a job that involves routine tasks, whether physical or cognitive, start thinking about how to make yourself indispensable. Learn skills that robots can't easily replicate. That means creative thinking, emotional intelligence, complex problem solving, and skills that require human judgment and ethics. If you're a parent, think about how you're preparing your kids for this world. The jobs they'll have in 20 years might not exist yet. The skills that matter will be adaptability, continuous learning, and comfort with technology, but also empathy, collaboration, and other deeply human skills. If you're an investor, yeah, robotics is probably a good bet long term. But be selective. Most of these companies will fail. The winners will be the ones with solid technology, realistic business models, and the capital to weather the inevitable bumps. If you're a policymaker or in a position to influence policy, for God's sake, start having these conversations now. We need regulations, safety standards, retraining programs, and social safety nets. We can't wait until robots are everywhere and then scramble to respond. And for everyone, pay attention. This technology is moving fast, and decisions being made right now will shape the next 50 years. Who builds these robots matters. Who controls them matters. What values we embed in their AI matters. These aren't just technical questions. They're social and political questions. Also, maybe cut yourself some slack if you're feeling anxious about all this. It's okay to be uncertain. It's okay to have mixed feelings about robots taking over jobs while also being excited about the possibilities. This is genuinely complicated, and anyone who tells you they have it all figured out is lying. Look, I'm going to level with you. After spending months researching this, talking to engineers, economists, ethicists, and people whose jobs are being automated right now, here's what I've concluded: the robot revolution is happening. Not might happen, not could happen, is happening right now, while we're sitting here talking about it. Factories in China are cranking out thousands of robots. Labs in Boston are teaching machines to manipulate objects with human-like dexterity. Companies are raising billions in funding. Governments are writing checks for military robotics programs. The question isn't whether this technology will change the world. It will. The question is whether that change will be on our terms or whether we'll just let it happen to us. And honestly, right now we're mostly letting it happen to us. We're reacting rather than planning. We're excited about the cool demos while ignoring the hard questions. We're allowing companies and governments to make decisions that will affect everyone without much public input or oversight. That needs to change. Because here's the thing, robots aren't inherently good or bad. They're tools. Tools that can be used to improve lives, or tools that can concentrate power and wealth. Tools that can free us from drudgery, or tools that can render us obsolete. The outcome depends on the choices we make. Do we want robots to serve humanity? Or do we want humanity to serve those who control the robots? It's a big question, maybe too big. But it's the question we need to be asking, so that's it. That's the full picture as I see it today. The Chinese are building fast and cheap. The Americans are building capable and dexterous. The military is building scary and autonomous. The money is flowing, the technology is advancing. And most people are just watching from the sidelines, not quite sure what to make of it all. My advice? Stay informed, stay skeptical, don't believe the hype. But don't dismiss the potential either, and for God's sake, Let's have this conversation as a society before decisions get made for us. Because one way or another, robots are coming. The only question is whether we'll be ready when they arrive. Thanks for sticking with me through this. I know it was long, I know it was heavy at times, but this stuff matters, and if you've made it this far, you're the kind of person who gets that. So keep learning, keep asking questions, and let's figure this out together. Because that's the only way we're going to navigate what's coming. All right, I'm done. See you in the future. Hopefully it's the good one.